Well, welcome to my YouTube channel. And today we are doing about differential equations, Laplace of differential equations. Okay, let's go. Laplace of differential equations. Today we are handling that topic, and we'll take an example of d squared x over dt squared plus 5 dx over dt plus 6x is equals to e raised to power 4t. Now we'll start by this value over here, the Laplace transform. We'll rewrite like this. Rewriting, it will be d squared x over dt squared plus Laplace transform of 5 here, because of this 5, dx over dt plus 6 Laplace transform of x is equals to Laplace transform of e raised to power 4t. Okay, now we have our expression written like this. So this one can be written as this d squared over x over dt squared can be written as x double prime. Therefore it is Laplace transform of x double prime plus 5 Laplace transform of x prime, dx over dt is written as x prime, plus 6 Laplace transform of x is equals to Laplace transform of e raised to power 4t. And Laplace transform of e raised to power 4t, we can assume or replace 4 with a, so that we get a general knowledge of Laplace transform of e raised to power at. Today I want to combine them together. So Laplace transform of e raised to at, we remember that Laplace transform, the formula is equals to integrating from 0 to infinity e raised to negative st e raised to at dot dt. Combining these, you see this is a, and these are values that are put on the indices. So we can rewrite that equation as, or that expression as, e raised to negative s minus t plus, because this is multiplication, so we can say e raised to negative st plus at dt. And because we are adding, we see that there is a t which is common amongst these values. And now we can say, integrating from 0 to infinity, e raised to negative s minus a. We've removed the negative outside, so that when you multiply negative by negative, you get positive. And we put the t outside, then we write dt. So we are not done. We are still integrating the exponential raised to negative into brackets s minus a, close the bracket, t. And this is what we do now when we put now the limits, because we have the limits as 0 and infinity. So integrate e raised to negative s minus a t with respect to t. We say now it becomes e raised to negative into brackets s minus a t over negative s minus a. This value that is on the exponential, this one comes down as a fraction, just the way it is, negative s minus a. Because we are integrating with respect to t, we don't put the t here below. So now that's what we have as the integrated portion of this. And now we say, we put now the limits, which is 0 and infinity. Now we can put our limits into the expression, which is e minus s minus a infinity over negative s minus a minus e minus s minus a times 0 over minus s minus a. Hope you are together until there. So now we come and now dissolve. So this one tends to 0, because we'll raise this to negative infinity, and anything we raise to negative infinity tends to 0. And here we come now, this is e raised to 0, because minus s minus a times 0 is e raised to 0. This is over minus, so remember that we have this negative here, because this is 0 minus this one here. So this minus can come up here, because this it is like its possession. So s minus a, so minus 0 minus e raised to exponential raised to 0 over s minus a, so which is equals to anything. When we raise exponential to 0, we get 1. Remember that this is minus times minus, you get positive, that is a plus, so over s minus a. So now we say, now for our case, that is e raised to power 4t, for the Laplace transform of e raised to power 4t is equals to 1 over s minus 4. Remember this 4, we say let 4 be our a. So now we come and say that we replace this, the a here, the 4 here, with our a, so that we get 1 over s minus 4. So we have already gotten that our Laplace transform of e raised to 4t is equals to 1 over s minus 4. So what we are left with is finding the Laplace transform of x double prime, and Laplace transform of x prime, and Laplace transform of x. So now we rewrite the expression or equation as is equals to 1 over s minus 4. So now we begin solving for this. So L of x double prime is equals to Laplace transform of x double prime is s squared. S squared, I want to, then there is s power 1, then there is, sorry, this is minus, not plus, minus s power 0. Now we introduce, when we say s squared, we multiply by L of x, because we are dissolving this one to become this part. S power 1, then we multiply it by x of 0. Remember that we said earlier that our dx over dt, which is equals to our x prime, is equals to 3. Our x is equals to 2. So now we come, this is s prime is s prime x into brackets 0 minus s power 0 into, that is x into 0, x prime into 0. Remember that we have this one is a double prime, so here it must go to until a single prime of x. But now s reduces, x increases. Hope you get that point. Our s decreases in power, in the exponential powers, and our x goes while increasing. So this is x power 1, this is x power 0, this is x power 1. So we come and say, we replace these values here, so it will be s squared L of x. This s power 1 will be minus s, but now this is x power 0, which is this can be written as x into 0. So x, not x power 0, it is x into 0. So it can be written as 2 times s, which is this one. S power 1 is s, so this can be 2s. So this 2 here, we replace it here, minus s power 0, which is 1. S power 0 is 1, so x prime 0 is this one, which is 3. So that we are done with that part. We come now to 5 L of x prime is equals to, we dissolve this part just as we have done to this. So it will come, this one will be s, because it's only a single s, it's only a single x here. So it will be s power 1 into, that is Lx s power 1. Remember that we are looking for the Laplace transform of the value x. So s power 1 Lx minus s power 0 in, that is x that way. So we already have this value, which is this value here, 2. So we can replace it straight away and say that s L of x minus 2. Are we together till there? The 2, we have 2 because this is x, not x0, and this is x into brackets 0. So this is 2. So this 5 here, and we need now to multiply this 5 into this so that we get 5 SL of x minus 10. Now we rewrite the whole expression or equation, putting all values in consideration, this value and this value, the expression. So we have s squared L of x minus 2s minus 3. This one here is what I've written here. Then plus, because this is plus, sorry, 5 SL of x minus 10. This value is what I'm writing here. Then plus 6L of x is equals to 1 over s minus 4. So we combine like terms together with L of x, L of x, all of x. We can see they are repeating. So s squared L of x plus 5, remember that this is 5 s L of x plus 6 L of x minus 2s minus 3 minus 10 is equals to 1 over s minus 4. Okay, so we can remove this one out of brackets. L of x we can remove, we can factor out L of x outside the brackets. So L of x into s squared plus 5s plus 6 minus 2s, remember this is minus 3 minus 10, we get minus 13 is equals to 1 over s minus 4. So we can remove this part and take it to this side, which will change to positive. So this is L of x into s squared plus 5s plus 6 is equals to 1 over s minus 4. This is plus 2s plus 13. This is over 1. So now we need to have a common denominator this side. So we'll say L of x into s squared plus 5s plus 6 is equals to, we need to have a common denominator here, which is s minus 4. So s minus 4 divided by s minus 4 times 1 is 1, sorry. S minus 4 divided by s minus 4 is 1. 1 times 1 is 1. So plus, this is 2s plus 13, because s minus 4 divided by 1 times this one. Then we close the bracket, we open for another, the s minus 4. So we need to open this bracket. That is 1 plus 2s plus 13 into s minus 4. So 2s, you open this bracket, this one and this one. So 2s into s minus 4 plus 13 into s minus 4. So this is 2s squared, 2s times 2s is 2s squared minus 8s plus 13s minus, that plus 13 times minus 4 is minus 52. So you get, remember there is a plus 1 here, so 1 plus, don't forget that 1 plus. Hope we are together. So this is 2s squared minus 8s minus 13s, you get plus 5s minus 52 plus 1, which you get, it is 2s squared plus 5s minus 51. Hope you are together until there. Okay, now L of x into s squared plus 5s plus 6 is equals to this value here, 2s squared plus 5s minus 51 over s minus 4. So we want to transfer this value here to this side. So we divide by s squared plus 5s plus 6 so that we'll be left by L of x. So divide also this side by s squared plus 5s plus 6. So this value and this one cancels. So you remain with L of x is equals to 2s squared plus 5s minus 51 over s minus 4 into s squared plus 5s plus 6. Thanks for watching. So that's the value that we are supposed to obtain, the Laplace transform of the differential equation. God bless you. Subscribe, like, watch. God bless you.